Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from three-dimensional geometry in which we'll discuss the concept of parallel planes, right? And here we'll solve this problem in which we have to find the equation of the plane mid-parallel to the planes whose equations are given here, right? So we have to find the equation of a plane which is parallel to these two planes, and at the same time this plane is equidistant from these two planes, right? Or in other words, this plane lies between the midpoint of the line joining these two planes, right? So let us start, and let us first draw a rough diagram of this problem so that we can visualize what we have to do in this problem. So now let us first draw these two planes, right? Suppose here we have the first plane, then we can draw the second plane like this. Here we have the second plane, and these two planes are parallel to each other, right? And we have to find the equation of the third plane which is mid parallel to these two planes, right? So here we can draw the third plane whose equation is to be determined, right? So this plane has the equation 2x minus 3y plus 6z plus 21 is equal to 0, and this plane has this equation, that is 2x minus 3y plus 6z minus 14 is equal to 0, right? And here our aim is to find out the equation of this plane, right? And this plane lies between these two planes, and moreover all the three planes are parallel to each other, right? So now let us name these planes. Suppose this plane is P1, right? And let us call this plane as P2. And see, this plane can be named as plane P, right? Okay, now here we'll discuss an important concept in parallel planes. See, suppose we have the equation of a plane as ax plus by plus cz plus d is equal to 0, right? So we know that the Cartesian equation of any plane is expressed like this, right? Now see, suppose we have to write the equation of some other plane which is parallel to this plane, right? So the equation of the parallel plane should be written like this, that is ax plus by plus cz plus d1 is equal to 0, right? So now if we closely observe these two equations, we can see that these two equations differ only in this constant, right? So this part is same in both the equations, right? So this is some plane and this is some other plane, but these two planes are parallel to each other, right? So always remember that any plane is expressed like this, ax plus by plus cz plus d is equal to 0. But if we have to write the equation of any plane parallel to some given plane, then this part, that is ax plus by plus cz part, remains the same, and the parallel plane differs only in the constant, right? So now in the given problem, we can see that we have three planes which are parallel to each other, right? P1 is parallel to P, and this P is also parallel to this plane P2, right? So now see, the equation of plane P1 is 2x minus 3y plus 6z plus 21 is equal to 0. And the equation of the plane P2 is 2x minus 3y plus 6z, and here we have minus 14, right? So these two planes are parallel, so the equation of these two planes differ only in the constant term, right? So here we have plus 21 and here we have minus 14, right? And this algebraic part, that is 2x minus 3y plus 6z, is remains the same, right? So we have to find the equation of this plane, right? Which lies exactly between these two planes. So the equation of this plane P can be written like this, that is 2x minus 3y plus 6z, and here the constant term differs, right? So here we can simply write d, and this is equal to 0. So the equation of plane P can be written like this. So all the three planes have this part common, but the constant term is different in all the three parallel planes, right? Now let us take some point on this plane P, right? Suppose the coordinates of this point are given by x1, y1 and z1, right? And let us draw a line like this. So here we have this point as say A, this point as B, and this point as C, right? So now in our given problem, we are given that this plane P lies mid-parallel to these two planes, right? So it implies that this distance AB must be equal to the distance BC, right? So here the distance between the planes P1 and P should be equal to the distance between the plane P and P2, right? So here we'll also utilize the concept of distance of a point from a plane, right? So here what we will do, we'll try to find out the distance of this point B, which lies in our plane, whose equation is to be determined. So we'll find the distance of this point x1, y1, z1 from A and from C, right? So now let us quickly recall the formula for determining the distance of a point from a plane, right? Suppose see here, if we have a point say P having some coordinate x1, y1, z1, and here we have a plane, say the equation of this plane is ax plus by plus cz plus d is equal to 0, right? And suppose we wish to find out the distance of this point P from this plane, right? So what we will do, this distance, this perpendicular distance of this point P from this plane is given by the formula is mod of ax1 plus by1 plus cz1 plus d, and divided by the square root of the sum of the squares of the coefficients of x, y and z respectively, right? So here we have a square, here we have b square, and here we have c square, right? So here we take the mod of this expression, right? So what we will do, we'll substitute this point x1, y1, z1 in the equation of the plane, and then we divide this expression by square root of a square plus b square plus c square, right? So here to find out the distance of this point from A and C, we'll make use of this result. So now AB can be written as, see the equation of plane P1 is 2x minus 3y plus 6z plus 21 is equal to 0. So we'll substitute x1, y1, z1 in this expression. So we have mod of 2x1 minus 3y1 plus 6z1 plus 21, and divided by square root of 2 square plus minus 3 square plus 6 square, right? And here for getting BC, what we will do will again substitute x1, y1, z1 in this equation. So we'll have mod of 2x1 minus 3y1 plus 6z1, and here we have minus 14 divided by square root of 2 square plus minus 3 square plus 6 square, right? So we can see that in this equation this term get cancelled, right? Because here we have 2 square plus minus 3 square plus 6 square, which is square root of 49, that is 7, and here also we have 7, right? So these two quantities get cancelled. So now we have mod of 2x1, that is absolute value of 2x1 minus 3y1 plus 6z1 plus 21, and here we have mod of 2x1 minus 3y1 plus 6z1 minus 14, right? And here we have the mod sign. Now see, in the equation of this plane P, we have 2x minus 3y plus 6z plus d is equal to 0. So this is the equation of this plane. And this point x1, y1, z1 lies on this plane. So this point, that is point B, must satisfy the equation of the plane P, right? So here we can substitute x1, y1, z1 in this equation. So we'll get 2x1 minus 3y1 plus 6z1 plus d is equal to 0. So now we can have 2x1 minus 3y1 plus 6z1 is equal to minus d, right? So the value of this expression is now equal to minus d. So what we will do, we'll substitute here and here this quantity minus d, right? Because once we know the value of this constant d, we can easily find out the equation of the plane P. So now we have mod of minus d plus 21, and here we have minus d minus 14, right? Okay, so now we have an equation in D in which both the sides contain the absolute value function sign, right? So now in order to solve this equation, we'll make use of an important result from algebra. That is, if we have mod of P is equal to mod of Q, then we can remove the mod sign from both the sides by writing plus minus P is equal to Q, right? So here we have the value of P is minus D plus 21 and Q is minus D minus 14. So we can now write plus minus, and here we have minus D plus 21, and here we can write, see here, mod of minus D minus 14 can be written as simply mod of D plus 14. So that is simply equal to D plus 14, right? So now here we can form two equations, one corresponding to the positive sign and the other corresponding to the negative sign. So the first equation is positive minus D plus 21, and here we have D plus 14, and the equation corresponding to the negative sign is minus D plus 21, and here we have D plus 14, right? So first we'll solve this one. So we have minus d is equal to 14 minus 21, right? Taking this d to this side and 21 to this side, we have minus 2d, and this is 14 minus 21 is minus 7, right? So d is minus 7 over minus 2, that is simply 7 over 2, right? And if we solve this equation, we'll get minus minus plus minus 21, and here we have d plus 14, right? Now see, here d minus 21 cannot be equal to d plus 14, right? So this situation is not possible, right? So we can now restrict ourselves to this value of d, which is 7 over 2. So now substituting this value of d in this equation, the equation of this plane P can be written as 2x minus 3y plus 6z plus 7 over 2 is equal to 0, right? And multiplying both sides by 2, we'll get 4x minus 6y, then 12z plus 7 is equal to 0, right? So this is the required equation of this plane P, which lies mid parallel to these two given planes, right? And moreover, we can easily see that the equation of these three parallel planes differ only in the constant term. Here we have 21, here we have minus 14, and we have just calculated the equation of this plane P, and here we have 7 over 2, right? So this is how we can solve these type of problems.